Hi everyone. Today's lesson is on scatter plots and trend lines. A scatter plot is a graph of paired data in which the data values are plotted as x and y coordinates. Now remember, the x-axis is our independent variable and the y is our dependent variable. Correlation is the degree to which two variables are associated. They can be positively associated, where the relationship in a paired data in which the two sets of data tend to increase together. So when you graph this, the line is actually going to go from the lower left to the upper right. It's going to have a positive correlation. It's going to go in a positive direction. We also have negative associated data, which would be referred to as a negative correlation. Here, a relationship in paired data in which one variable's values tend to increase when the other one decreases, and vice versa. So you can either have an increase in your x and a decrease in your y, or a decrease in your x values and an increase in your y. Okay. When you graph these, you're going to see a pattern and a line drawn from the upper left down towards the lower right. And if there's no correlation, that means that the relationship in a paired data where there is no apparent pattern. Okay, your dots are going to be all over the place. And if you look here, this is what your positive correlation would look like. Here's an example of the negative, and here's something where there's no correlation. If you look at the example up here in the corner, this one would represent another negative association. This one, my guess would be positive. Here's another one. That would be negative. And one final one we'll look at. And this one, the dots are all over the place. So there would be no correlation there. Okay, a line of best fit is a straight line drawn through as many points as possible, with approximately the same number of points above the line as there are below the line. So here we have an example of a negative correlation. The line goes through the data, and we have just as many points above the line as we do below it. And here's one that shows a positive correlation. Again, we take the ruler, try to line up some of the points if we can, and you want as many points above the line as there are below. Draw the line of best fit for the given scatter plot. And again on this one, we're going to take the line and place it right in the center. You try to hit points if you can. Sometimes it's not always possible. But the more important thing is you want to try to get as many points above the line as there are below it. And this would be our line of best fit. The data below shows the relationship of hours 7th graders study a week and the grades they receive on a math test. Based on the given information, about how many hours would a student need to spend studying per week to get an A, 90% or better, on the math test? The first thing you want to do is graph the data. And on this one, We have the hours studying down here and the percent over here. So we would go to 1/4 and then up to 20%. So if you put in 15 minutes, it means you're going to get about a 20% on your test. Sorry guys, hang on. My bad. All right. So you would go over to 25% or 1/4 of an hour and go up to 20%. Put a dot. The next was 3/4 and we were up to a 25% on the test. 1 hour, we jumped up to 40. An hour and a quarter, we're still at 40. An hour and a half, we jump up to 50. Two and a half hours, we go up to 55. And another one that was at 2.5 hours was at 60%. So now what you want to do is try to draw a line through it. And I definitely suggest a ruler for this. Okay, we can pass through one of the lines. Or one of the points. And continue straight up. As you can see, we have half the points above the line, half the points below. Now the question was, how long do you have to study in order to achieve a 90%? And if you follow the trend line up, 90% correlates to approximately 4 3/4 hours worth of studying. Let's take a look at this one. Is this a good line of best fit? And the answer is no. The point 2-4 is an outlier. The line should be shifted up to fit the majority of the data. So this line should actually be up in here someplace. Use the data and place the line of best fit. Again, here's our data, our line of best fit. Should run right in the middle of it. Again, you try to hit as many points as you can, and then you try to balance out the number of points above the line and then the ones below the line. If you needed an equation, you should be able to, using all the other skills you've already learned, come up with an equation for this line of best fit. Which graph has the line of best fit, and what's wrong with the other one? Okay, the line on the left just goes through the first and last data point, and it does not have an equal number of points above and below the graph. Here's one more. Which one's better? And it would be our second one. The first one actually shows a negative correlation, but the line is going in the wrong direction completely. So even though there are 4 points above the line and 4 points below, the line's not matching up to the correlation, where in this one it is.